Today we're going to be working on calculating for the mean and the standard deviation of a discrete random variable. When you're performing this type of statistical operation, you need to make sure that you are understanding the table that is being given to you. The x values here are your random variables, and in this example, x would represent the number of males in a group who have a form of color blindness, and p of x would be the probability that that particular number of males has some form of color blindness. So for example, 0 of p of x given by 0.684, it means if we have p of 0, that means the probability that there's no males in that group or group that has some sort of color blindness is 0.684 or 68%, which probably means that that particular group of individuals are all female. That's why we have p of 0. And if we have p of 1, that means in that particular group, there is one male in that group, and the probability that that particular group of male has some sort of color blindness would be 26.4%. And that is how you are understanding, or how you should read each of these individual values in your table. And the first thing that we need to do is to verify if this is a legitimate probability distribution model. And to be able to do that, we just need to satisfy the conditions that the sum of all your p of x, or the probability in your distribution, is going to be equal to 1. And in this case, if we add them all up, it's equal to 1. Therefore, we have a legitimate probability distribution model that we can use in computing for the mean and the standard deviation of this model. So to start with, we're going to be computing for the mean. And to compute for the mean, the formula is a little bit complicated because of the Greek symbols and a lot of letters in your formula. But if you are understanding the language of math, this is basically pretty simple. So the mean is the summation of x times p of x. And this symbol right here, it means to add them all up. So that thing that we're going to be adding together will be the product of x and p of x. So going back to our table, we have x column and p of x column. So all you need to do is to multiply the corresponding values of your x and p of x. So if I have 0 times 0.684, it's equal to 0. You don't even need a calculator for that. The second one, also, you don't need a calculator because you only need to multiply 1 by 0.264, which is also 0.264. For the next one, we have 2 times 0.045. So this time you will be using your calculator, and it will give you 0.09. And for the next one, it's 3 times 0.006. And one thing that I want to emphasize is that you need to be careful with how you use your calculator and how you write out your answer. Because what you're seeing in your calculator may be correct, but what you are writing may be incorrect. So make sure that you are being careful with what you're doing in your computations like this, because the math work in this problem is pretty basic, but you need to be accurate in every little move that you are doing. That's why instead of writing 0.018, I wrote 0.0018, which is wrong, and one small mistake like that will ruin your calculation. So make sure that you are being careful with your calculation so that you don't end up with the wrong answer. And now that we have the column for x times p of x, all we need to do is to apply the formula, which is the summation of x times p of x. That means we're going to add all the new column that we have, and that sum, using your calculator, is going to be the mean of your random variables, which is 0.376. So the expected value, or the mean of your distribution, would be 0.376. So that is the expected number of males who would have some sort of color blindness or form of color blindness in this particular sample. Now for the standard deviation, we'll have another set of formula, and there are two sets actually, and we're going to be using the first one, which is the square root of the sum or the summation of x squared times p of x minus mu squared. That's why whenever you're computing for the mean and the standard deviation, they always go together, because you're not going to be able to compute for the standard deviation without the mean. And now that we know the mean, which is 0.376, we just need to worry about two things: the value of x squared, which is not in the table, and x squared times p of x, which is also not in the table. So we're going to be constructing two columns for those values. X squared is pretty basic, because all you need to do is to square all your x's. You don't even need a calculator for this one. So 0 squared is 0, 1 squared is 1, 2 squared is 4, all the way to 25. And again, we're doing this table form of our calculation because working problems or working with too many numbers in statistics needs to have a more organized way on how you compute for it. And using a table of values would really help you understand and see how the transformation of your values is going or working on, and just like what we're doing here right now. And now we're going to produce the last column for our solution, which is x squared times p of x, and you're going to be using a calculator for this one. So the first one, it's just 0 times 0.684, which is 0. The second one, you don't need a calculator because it's just multiplying by 1, which is 0.264. Now the third one is x squared times p of x. So x squared at the third row is 4 multiplied by p of x on the third row, which is 0.045, which will give you 0.18. So multiply the corresponding values and you will end up with the column for your x squared times p of x. Now, why do we need that column? That column represents the Greek formula that you are seeing in your standard deviation formula that you will use to be able to compute for the standard deviation. And now that we have all the ingredients we need, all we need to do is to pray to God that we are using the calculator correctly, and 3, that we are writing what is the calculator is showing correctly. So here we have the summation of x squared times p of x. So we're going to be adding that last column, and it's equal to 0.514. And we're going to incorporate that in the formula for the standard deviation, which is the square root of the summation of x squared times p of x minus mu squared. And plugging them all in, we'll have the square root of 0.514, which is the third column, minus mu squared or mean squared, which is 0.376, which we calculated a while ago, and you need to make sure that you square it or raise it to the power of 2, and using your calculator once again, we'll have the square root of 0.379311. Now in statistics, if we don't put the square root or calculate the square root of that value, that is called the variance. And then the standard deviation is the square root of the variance. So we'll have 0.615 using our calculator. So to sum this all up, our mean for our random variable will be 0.376, which is the expected number of male in the group who would happen to have some sort of color blindness in their eye condition, is about 0.376, and its standard deviation, or how it's dispersed on the normal curve, is 0.60. And this is how we compute for the mean and the standard deviation of a random variable. This is Dr. Speranza, and thank you for watching. Bye! How to compute How do you calculate the mean and the standard deviation of a discrete random variable? This is Dr. Speranza, and welcome to my Math in a Minute. In performing